Ladies and gentlemen, welcome back for the second session of the day in room 9, optimizing SQL queries in Business Central, given you by Milan Milincevic. Please give him a welcome.
Thanks, everyone. It's a great pleasure to hold a talk in conference like this. First of all, I would like to thank the organizers for this wonderful opportunity. And today's topic would be optimizing SQL queries in Business Central. My name is Milan Milincevic. I'm BC developer from Croatia. I'm currently mainly working with Danish company called NaviPartner. I'm in Business Central and Navision world 4 years for now, and I'm sure that I still have a lot to learn, but I hope today you will learn something from me. Today I will be talking about indexes. I will cover what is the index, why we need it, type of index. After that I will cover something about cluster and non-cluster indexes. We will demonstrate how we can quickly calculate sums and talk about considerations that we need to take when using indexes. And we will check some new feature in Business Central and much more. Let's start. I am sure that many of you know that index is a quick lookup table for finding records users need to search frequently. SQL indexes are primarily a performance tool, so they really apply if a database gets large. And indexing a table or view is, without a doubt, one of the best ways to improve performance of queries and applications. Let's see what Microsoft says about indexes. And index is an on-disk structure associated with a table or view that speeds retrieval of rows from the table or view. An index contains key, build, blah, blah, blah. SQL Server supports several types of indexes, but one of the most common types are clustered indexes. These are the index which is automatically created with a primary key. SQL indexes are fast partly because they don't have to carry the data for each row in the table, just the data that we're looking for. This makes it easy for operating system to cache a lot of indexes into memory for faster access and for the file system to read a huge number of records simultaneously, rather than reading it from disk. Let's find a bit more about clustered index. Like I said, this is index which define the physical order in which table records are stored in database. Since there can only be one way in which records are physically stored, there can be only one cluster index per table. By default, cluster index is created on a primary key column. Of course, we can create a table where primary key will not be clustered. The following image illustrates a logical structure of cluster index. This sorted data structure is called a B tree or balance tree. B tree structure enables us to find the queried rows faster using the key values. We have 3 levels, like you can see. The main is the root level. Everything starts from it. And after that, we have intermediate level. This level provides just a connection between root and leaf levels, so SQL Server does not need to create an intermediate level when we don't have a much amount of rows or data in our table. So we see that the lowest level is the leaf level, where cluster index, all of the data are stored in that level, meaning that when we want to search, for example, for value number 5 or record number 5 in the database, when we're using a cluster index, we will just start from the root level, then we will go to left to 1 to 11, then to 1 to 6, and you see, we don't need to scan the whole table. We will just go from up to down. And because of that, this cluster index is very, very efficient. Other index type is non-cluster index. Yeah, this non-cluster index is similar to the index of a book, because index of a book consists of a chapter name and page number. So if you want to go to some specific page number of the book, you don't need to go through all of the pages. You just need to look at the index and go to that specific page. So meaning on non-clustered indexes, data is stored on one place and index is stored on another place. So meaning, because this data is stored separately, we can have multiple non-clustered index in a table. Yeah, I'll maybe just connect to SQL Server to just show you. So I'm sure many of you know about SQL Server Management Studio, and I'll just take a look at table. Wait a minute. Let's do it this way. Sorry about that. Okay, I created some tables, but we'll get to that later. I just wanted to. Okay. But my PowerPoint is closed. I can. I think something is wrong. Okay, thank you, sir. But now I can see. I don't see what is on my screen. Yeah, but Sorry about that. I wanted just to look at some table and to see what type of keys we have there. For example, on no worries. Perfect. Yeah. Finally. Thank you. So if you look at the demo table that I created, we can see that we have a few keys. Key is actually okay. Let's just maybe it's not okay. Yeah, I will just do the slides. Maybe it's easier that way. Just to be clear about terminology. So, a field which has a unique value is essentially a key. However, a key is used to uniquely identify a row in a table, while an index is used to sort a group the rows in the table. So, key should not be changed, even if we can it once it's been initially set, as it might be a reference to somewhere else in our database. An index field, however, can change freely. So, on Business Central level, on each table, secondary unique key was created on system ID field automatically. That way, we are sure that when we insert system ID field, we cannot change it, never. But primary key, we can rename the tables. Yeah. Okay. Table on the keys, table keys. When defining index in Business Central, it is under a key section on a table or table extension. So meaning key in Business Central is index in SQL Server. First key in section is primary key, and it is clustered by default. Of course, we can put parameter cluster to be false, so then we would not have primary key to be clustered. We can add cluster to some other field as well. Also, about that system ID field that I mentioned earlier, it is not visible in Business Central AL. So it's created automatically on SQL Server, but you don't see it here on that screen. I'm sure that all of you knows that it's possible to create a key on standard tables as well. The main trick here is that we cannot combine standard fields with our custom ones. So yeah, we should be aware of that. But before we look at indexes in Business Central, we should clear things about set current key. It is used to sort by specified fields. It will not select which index to use. It can help with choosing the index because of the sorting, but at the end of SQL Server may choose a different key based on statistical distribution of values in a field. We can use, before we look at, we can use any of the fields as parameter to sort by, even those fields aren't defined in the key section. So earlier version, if we add a field in set current key which isn't defined in key section, it will show runtime error. But now we can add in any key, whatever we want from the table to sort by. Caching, caching is one of the methods which system use to improve performance and respond to requests rapidly. In a Business Central system, caching is done on two levels. We have a Business Central Server instance data cache, and we have SQL Server data cache. So whenever a user requests a data from Business Central, it first checks whether data is available in the server instance cache. If not, then it checks the SQL Server data cache. And if not there, then it goes to the database to get the data. We have two types of cache stored in Business Central Server. There are global cache and private cache. So global cache is basically one which is accessible to all the users connected to the SQL Server. Private cache is only accessible over a transaction, meaning for a particular user, for a particular company. This cache is cleared as soon as the transaction is completed. Which cache is to be used for which user depends on whether the table from which the user is requesting data is locked or not. In case it is locked, private cache is queried, else global cache. And we have select latest version method. Make sure that the data displayed is the most current data in the database. Also on SQL Server, on SQL Server level, we have two commands: drop clean buffers cache, which will clean the cache, and we have free pro cache, which will clean the store procedures cache. I'm sure that we all using our partial records, because this is such a great functionality that help us loading just a subset of normal fields when accessing a SQL-based data source. Using partial records improves performance of objects like reports and data pages, but it's particularly beneficial when table extensions are used in the application. Sorry. Accessing a data source from AL code is typically done using records method like get, find, next, and so on. Without using partial records, the runtime will load all normal fields from the data source. So I'll just, we have 4 methods available for partial records. This is a set load fields that will help us to initially set the fields that we want to load, and then after that, for example, if we are in some subscriber and we need to some new fields from it, we can just use add load fields method, which will just basically add new fields to already existing ones that are set in set load fields. We have our fields loaded and load fields method also. There was one particular problem with partial records. It was it would require all fields that are used as filters in calc formulas or flow fields to be always loaded. Meaning, even if we have in our table extension some flow fields, and even if we don't want any of those fields, partial records still will be doing a join. And because of that, we will lose a lot of performance benefits that we could gain. But fortunately, this is solved in version 21, so the partial records would be even better. How it's solved? It's two-part solution. Okay, sorry. A two-part solution. It is for calc fields, the direct solution is to just-in-time load the fields needed for filtering on flow fields. For Smart SQL, the fields will be selected for all if filtering on flow fields of all flow fields are selected for automatic. We have a few benefits of partial records. I already mentioned some of them, but because the fewer columns in select part, there is a better chance of the SQL optimizer to pick an index. Also, less memory allocated by SQL Server will be to execute the query. Because of the smaller data set, we have faster data transfer between NST and SQL Server. And because of that, potentially less I/O on SQL Server to fetch non-cache data, because we are getting rid of joins, and less memory will be allocated. And one of the benefits is better utilization of execution plan cache in SQL Server. I will just switch to my code if I will be successful in that. We'll see. Yeah, okay. So I'll not be measuring performance, because we all know partial records would help us to gain better performance. I just want to show what is the difference in the SQL level in the query. If we have query with find set with partial records where we want only to load amount and start date, for example, in our data set, we just wanted to do something with that. And the other situation is when we will not use partial records. And when we go back to presentation, we will see that this is the first SQL statement where we only have these few fields. We have timestamp, we have primary key, we have this. No, sorry. This is the first one without partial records, meaning we have a join on our extension as well and all the fields from the table. But if I go now to the partial records, we only see the fields that we accessed for. There are start date, amount, and primary key and system fields. When we are using partial records, we need to be extra careful to not trigger just-in-time loading. And this is basically when we try to access unloaded field, platform will detect that access field is not loaded, then it will issue a get on the record and load the requested field. In the end, it will update the record with newly loaded values. Error is raised if record has been changed in the database before fetching the just-in-time load. So we should be aware that delete, rename, and insert operations require to all fields to be loaded, meaning that this operation will trigger just-in-time load if we use partial records. So basically, we should mainly use partial records with find, get, find, set, and so on. Covering index. Covering index or included column is a new feature in Business Central from version 20. On SQL Server, it is also called covering index, and it is special because we have possibility to define extra field in index, which values are stored on leaf nodes on index. So biggest benefit of that is it contains all the fields required by query, so when we are executing the query, we don't need to go extra to the table to get extra data. It may greatly improve performance, and the best results are often achieved by placing fields required in filter or drawing criteria into index. So I'll just, for example, if we have a statement like this where we'll want to select description and description 2 from item table where item is okay and order by. Optimal index for covering index in our case would be that we have item NO at the first place is optimal seek, then we will have last modified date on the second place on the index, and in the included fields we will add description and description 2 columns. Yeah, okay, this was syntax, how it looks in Business Central. So basically, if we want to just include covering indexes, we just need to put those fields into included fields parameter or into key. Before covering indexes was declared, we needed to declare all the fields into our key. Why not put included columns? Why we need covering index in the first place? Yeah? If the included columns are not needed for other types of searches, keeping them out of the key list makes for shorter entries, and here the results is less index IO operations. Included columns also can be data types that cannot be index columns, and currently we cannot have more than 60 key columns in index. Also, if we put 60 columns into index, I think that we are doing something wrong. There are few use cases for covering indexes, and first one is query object. Query object is great if you want, because we will just in query object select a few fields that we want. We will add order by clause if you want, and then we have filtering situation. So another use case would be combining it with set load fields. This is actually the main benefit of partial records and set load fields, because set load fields are just gets us a few fields that we want, and partial records we can declare those fields. So meaning we don't need to go extra to the database to get other fields. And maybe it's a good thing to do to revisit all of our existing keys to check whether there are candidates to be changed, to be covering. Index plus view, that is basically index view. After unique cluster index is added to the view, we can add more non-clustered indexes to it. Also, it is possible to create a non-clustered index on a view, providing more possibilities to enhance the queries calling in the view. That makes it actually the stored data. So I don't know, does anyone of you knows what are views exactly in SQL Server? Can you maybe raise a hand or so? I don't know. Okay, so okay, I'll go back. Index views are basically virtual tables that are used to retrieve a set of data from one or more tables in a SQL Server. But it will not actually store the data. It will just help us to our query looks easier, simpler. But for example, if we want to fetch the data from some view, we will just go to the database and get the data still. But what's happened if we add an index to a view, I mean unique cluster index, then like we said earlier, unique cluster index is used to sort physically data in the table, meaning when we add the index unique cluster to the view, we will get actually data stored in that indexed view. Also, of course, it is possible to create non-cluster indexes on a view, providing more possibility to enhance the queries calling the view. That makes it actually, yeah. Okay. Creating a unique cluster index on a view improves query performance a lot, meaning because we are just have grouped values on a view, and when we want to fetch it from the data, we will just get it very quickly. But the problem here is when we would try to, okay. One of the main considerations here is to insert, modify, and delete can degrade a lot, meaning every insert, every delete, every modify that we did in our basal table, we also need to change in our index view. So even if we have a very good performances, if we're getting the data, we will have poor performances when we are inserting or modifying a data. We can benefit from index view if the data is not frequently updated. If the performance degradation of maintaining the data changes is higher than the performance enhancement of using this indexed view. Indexed view improve the performance of queries that use joins and aggregation in huge amount of data and are executed very, very frequently. So why was I saying that about index view? Because some index field technologies is basically done on index view. When we add a SIFT key in our table, in our key section in Business Central, this is basically indexed view in the SQL Server. And because of that, it is blazingly fast when we want to get the sums or some other aggregation, but it is very hard to insert the data. Also, it was important to know that each SIFT key that we add in Business Central table, it is new index view in a SQL Server. Maybe I'll just switch again to. Are you kidding me? Yeah. Sorry, I have new problems. Okay, yeah, okay. Thank you. I'll just, on the SQL Server, we have view section, and I will just filter my views to. Okay, so we can see that these two, this is the table called demo, and we have SIFT key 2 and SIFT key 3. That means actually that if I look in the, okay, if I look into my demo table, at the key section, I have two SIFT keys. One about with amount and one with amount 2. So I'll just go back to the server. So if we select this view to, maybe I'll just use top 10. Okay, when we look into that view, we can see that we have car and no column, we have start date, we have count, and we have sums. And when we go back to the code, we see that in our SIFT key, we added car and no as a start date as indexes, and as a sum index, we added that we want amount. And what we basically see in a SQL Server, that means for each combination of car and no and start date, we will get some amount and we will get count. So basically, when we do count operations on our SIFT index on table, it will be also very fast because it don't need to go to the base table to count all the rows, or it don't need to go to the calculate all the sums. It will just need to do a few sums from here, and because of that, it is basically fast. Maybe I can show some example in SIFT. Okay, what I created is a demo table. It has a few fields, and I filled 5 million of rows into this table. I have a car table and I have color tables as well. So when I go to the to the Business Central, and if I go to the demo list, this is a page of my demo table. We'll see all of that data. What I did actually also, I created a car totals table on which we have a few calc fields. And since on the page we will add a total amount field, so if we go back, we see car totals page that have car name field and total amount field, and total amount is basically the flow field to the demo table. And because of the SIFT key, if we go to the cars total, what we will see, it is blazingly fast. I mean, we have 5 million rows, and this calculation is done in a second, or less than a second. Also, one of the main things when using SIFT indexes is that when we using calc fields function, we shouldn't use it in the loop. Meaning we should use set auto calc fields before find set. So I made also one one example as well. What I did, I created two functions. One function is we will go through each of our cars and we will just calc fields of our amount inside the repeat statement. Other example is we will use set autocalc fields outside of the find set. And when we start, okay, I need to go to the car. And if I add the action calc fields, compare calc field was 77 milliseconds, and set autocalc fields is 0. Basically, we don't even have any. I'll just try one more time. 74. Yeah. We see that set autocalc field is faster a lot. I mean, in this situation. And yeah, this is, I didn't say that this is time. We have a property on the key, which is maintain SIFT index. It's true by default, so we don't need to put it. If we don't want to use the SIFT index, we can put it to false, but if we put that maintain SIFT index to false, basically the index view from the SQL server will be dropped, so we will not have SQL index, so we just could delete all the key as well. We could, if we put maintain SIFT index to false, and if we still have some index fields, we still can do calc fields, but that time it will not use index view, it will go to the table, and it will be a lot slower. Okay. As mentioned, there are a few considerations when using SIFT indexes. We need to do it optimally, meaning key that is defined and enabled for that table are maintained. So when we're doing inserts and modifies, since SIFT indexes are based on index view, maintaining these SIFT indexes has performance overhead. Of course, the size of performance overhead depends on the number of keys and some index fields defined on each table. This is all maintained only for large table. We don't need to use SIFT keys for small tables or tables that are only used periodically, because yeah, we can use alternative for SIFT field is included columns, because we will still have decent, I'd say, performances, and we will not need to maintain the index view, because included columns are just basically non-clustered index in the background. All of the indexes that I mentioned they are row store, meaning all of the data is stored horizontally. But there are column store indexes as well. That means that data is basically stored horizontally. We can only have one column store index per table, but we can add multiple fields, and order in which we add fields is irrelevant. So the reason is that each column that we add into our column store index is stored separately, and we will see that a little bit later. One of the easiest ways to think, we will just store data vertically. It is fast, or it should be fast, summing column, counting the number of rows, or and because of the advanced compression that allows more data in memory. If proper filters are applied if also provides a segment elimination, and later bit we will see what's that about and how we can test that. It reads batch of rows, and column store data is logically organized as a table with row and columns, and physically stored in column-wise data. We can, meaning if we have 5 fields in our column store index, that would be stored like this, like a table where each column would be present 1 field. And the column store index groups rows into manageable units, meaning each of these units is called a row group. So we have a lot of row groups, but these row groups are also some small tables, and we should have ideally 1 million of records in each row group to column store index to be optimized, to be perfect. But this doesn't happen always, and we also will see that. And we call segment each of these parts of our column store index. Each row group contains 1 column segment for every column in our table. So meaning each column has 1 column segment in each row group. When the column store index compress a row group, it compresses each column segment separately. And to uncompress an entire column, the column store index only needs to uncompress 1 column segment from each row group. If a segment is eliminated, that it means that whole row group is eliminated. And we have delta store as well. This is when we created when we inserting a new values into our table, into our index, they won't be at the start they won't be saved in the row groups. They need to be firstly saved in the delta store, and when we have enough of the data, then it will go to the row group to be compressed. To return the correct query results when we using column store indexes, cluster index combines results from both the column store and from the delta store. Non-clustered column store indexes. How many of you heard about non-clustered column store indexes? Okay, how many of you using non-clustered column store indexes? No one, okay. This is a new technology that Microsoft introduced, and it should be an alternative to SIFT indexes. In contrast with SIFT indexes that rely on the indexed views, this NCCI or non-clustered column store indexes in Business Central use only the non-clustered column store indexes feature. So there is no aggregated data stored in the non-clustered column store indexes. All analytical queries are done at runtime. So because of that, it should be really fast. I have some examples, so we will see about it. We don't need also to worry about order of the fields when we're creating non-clustered column store indexes, because each of these fields are separately stored. With SIFT keys, any insert, update, or delete operations to the underlying table will introduce some database locking, because index use must be updated as well. The more SIFT keys, like I said, we will have more maintenance and possibly the more locking problems. And that problem basically doesn't exist in our case in non-clustered column store index. Also, when we should using column store indexes, we need to have a very large table and very wide table. What does it mean? It means that it needs to have at least 1 million records, but basically it should have more than 5 or 10 or 50 millions, and it will perform good, very good. But also we need to have a big tables with a lot of different columns, because if we have small tables which are, I don't know, under 500,000 records or so, we won't row groups won't be compressed because at each row group, as I said earlier, we need to have 1 million records to be ideally. So it's important to have a lot of row groups and to have a good created index so we can eliminate all of these segments to be fast enough. Also, we shouldn't add string fields or highly unique values to the index. Best would be if we have some integer or date fields that can repeat from time to time. And if we use non-cluster column store indexes on tables that are updated heavily, then it will cause index fragmentation, so we won't have any benefits of an index. Like I said, there are few things to consider. Do we still need it at all? Meaning, if we have a not so big table, we shouldn't use it. Also, we won't gain a much benefits if we add all fields into our column store index. We should choose a few of them and then filtering. And we should test before we are disabling SIFT and changing into non-cluster column store index. I would just show on the SQL Server and on the Business Central how it's really stored. So I'll just go here. Okay. I have a demo 2 table. This is basically the same table with the same values as a demo table where we use it to calculate the SIFT values. I also have and on demo 2 table, I created column store index where I put car number, amount, and start date into my column stores. I also have a list page, and I will just run that page as well. So if I run my demo list page, you see it's pretty fast also, because this is 5 million aggregation of 5 million rows, and it's very fast. If I would do it again, we don't need to wait. No, sir, sorry, my problem. If we go to the car total, and here is the problem. We need to use our non-cluster column store index optimally, because you see this is very, very slow. And I mean, we should have a really big and really wide table to gain such benefit. Because of that, I asked earlier how many of you are using non-cluster column store indexes, because I didn't get very, very good, very fast results with it. Even I have 5 million records in a table. And I'll just run some queries, some query in the background to check something. So when I was talking about these row groups and segments, when we look into this table, we will notice that we have 5 compressed row groups into our non-cluster column store index, and we have 1 open. The first row is actually our data store, where we inserting a new values, and when it become big enough, it will just compress and go into one of the row groups. I did a small test with SIFT and NCCI on performing inserts and modifies. So if I go to my demo list page, and I have action to insert 1,000 row into this table, and if I use it SIFT index with it, okay, it is around 1 second. But if I use non-cluster column store index, this is 95 milliseconds. Meaning this index view, maintaining this index view in our case is 10 times slower than using non-column cluster store index. So yeah, like I said, if we have really big tables, we'll benefit a lot from non-cluster column store indexes because of these maintain operations. And how we can migrate to how we can migrate from SIFT to non-cluster column store indexes. Yeah, we said why, and we'll see how. Basically, we just should declare column store indexes on our table. We'll put fields that we want to replace the SIFT keys, and we will just remove the SIFT key from the table. And yeah, that's easy as well. When we deploy our app, it will take some time to create non-cluster index and to drop existing SIFT index. Data compression. Compressing table data saves space and helps improve performances also. These are two possible data row compression on SQL Server. We have a row level compression and we have page level compression. Row level compression is basically, it works by converting any fixed length of data types in our field into our actual value. For example, if we have some text, 150 fields, and if we only have a field into it that is 10 characters long, when we use the row level compression, it will just compress the field to that value. And we also have page level compression, which basically applies row level compression and also add two other types. Add much more. We can add the data compression parameter in our table just as a part. And we have also unspecified option. Unspecified option just means that we will handle our data compression on SQL level. So we won't take anything in the business central level, we will just define it on SQL Server level. Business Central Online has page compression enabled by default, and I think in most cases we should use it as well on-prem environments. There is a procedure estimate data compression on SQL. I will not show you today, but we can decide which type of compression to apply on a table. Because when we run that compression, that procedure, we can see what is the actual size of data, what would be if we apply row compression, and what would be if we apply page level compression. And if there is no big differences between those two of levels, then we should apply row level because it's simpler one. But if there is a lot of differences between size of the data, then of course we should use page level compression. Database locking controls access by multiple users to the same data at the same time, meaning to protect a transaction against other transaction modifying the same data. The first transaction put a lock on the data. That means that we should keep our transaction as short as possible, because if each of our transactions is longer, then there is a more possibility that someone will be blocked. Lock remains until the transaction is done, meaning, as I said, table locking is not bad things as such, but it's crucial to guarantee consistency of the data. Table locks which leads to blocking conflicts between two or more users can be critical because one of these users will wait until the other will need to finish their operations. And of course, more keys we have, more time is needed to write operations, and locks will be more often. In AL, there is a function called lock table, which calls subsequent reading to lock the table or parts of it. SQL Server is one who will decide will we lock the whole table or will log the only row. Meaning on SQL Server we can log the row. This is the lowest level of granularity of logging possible, and that means that one or more specific rows will be logged in the table, and all of other data would be free to use. And page log will log just SQL Server page. This is just a part of the table, and so more rows would be logged. And the table log, of course, will be log the whole table. I will just make a small also example. So what I did on my items page, I just used item log table function, and I'll just get some item, and then I have confirm. And if I go to my items, okay, are you sure you want to stop the log? This means, if we look in the code, we are now in the line 21 where we are waiting for confirm, meaning our code is still in the transaction. It caused the log. So if I go with and log in with another user in Business Central, okay. And if I go to the items as well, okay, sorry, I need to change the company first. So if I go to the items, and for example, this is the one, if you remember, we get the item 1000. And if I select that item, and for example, I want to change description to some test description, what would happen? If I go back, system will be blocked. System will not have us. But if I okay, I stop the locking now on my main session, and yeah, I wasn't fast enough, so it was already. It gave me an error that the session was blocked. But what will happen if I do this? If I lock one more time, and if I go with okay. And if I go with this user, for example, to record 1001, and if I decide to change the description here, then our description is changed as well, meaning we see that SQL Server used just a row level locking on this example. There are few things, few possibilities of that can cause locks in Business Central. One of these is, of course, log table functionality. Another one is if we use find set with update true parameter, then it will also raise a log table parameter. And another possibility is like this: if we don't have log table, but if the two users at the same time tries to block the same code. And I think in most scenarios, the most reason for locking is just a bad code or bad solution. This is not right in a good way. There is a feature in Business Central where we can see database logs that was happen on our environment. it is important to know that if we have multiple NSTs, and if locking happened on different NST, then it won't be showed here. Yeah. Also, there is a new feature for locking. This is from version 21. When we use AL debugger, when we debugging our code, under database statistics, we can see a log section where we would see logs that are currently happening. The main reason why we have this such a few features that we can maintain a log is because it's difficult to identify which logs are taken when we are in online, because we don't have access to our database, so these features could help us a lot. Database wait statistics. The wait times are captured and recorded by SQL Server, and all this captured information called wait statistics, it provides us assistance to resolve problems that are related to the SQL Server performance. Basically, what's happening in the SQL Server, it just call this demos wait stats, and it will give us a lot of information what's happening in the database. There are a few types of waits, and we have resource waits that occurs when a worker requests access to resource that is not available because the resource is being used by someone other worker or not yet available. Examples of resource waits are locks, latches, network, and disk I/O waits. Locks and latch waits are waits on synchronization objects. We have external waits which occur on when SQL Server worker is waiting for some external event. And specific types of wait times during query execution can indicate bottlenecks or stall points within our query. Similarly, high wait times or wait count server-wide can indicate bottlenecks or hot spots in query interactions with server instance. For example, lock waits indicate data contention by queries and so on. We have a lot of these types that we need to check when we have some of the bottlenecks in our database. The missing indexes feature on SQL Server consists of two components. One of these components is missing indexes element in SQL XML of execution plan back in the SQL Server. And second one is dynamic management view. This procedure missing index details, which can return us information about missing indexes. This allows us to view all the missing indexes and recommendations that SQL Server sees. With this capability, our platform will make data about missing indexes available as virtual tables, so the data can be accessed from AL code. The missing index feature suggests only non-clustered disk-based row store indexes. And there are few considerations about it. This was a lightweight tool for finding that significantly might improve our query performances, but what happens in the background? It's because when the query optimizer generates a query plan, it analyzes what the best indexes are for particular filter condition. If the best indexes don't exist, the query optimizer still generates a query plan using the least costly access methods available, but also stores information about these indexes. This feature enables us to access, so we can choose what index to use. There are no cost-benefit analysis, so regarding the size or included columns. Also, key columns are suggested, but this procedure doesn't suggest specify of order of these columns. Also, included columns are suggested as well, but SQL Server performs this cost-benefit analysis only of the size of resulting index when a large number of included columns are suggested. It may offer similar variations of index on the same table and columns across queries. It is important to review index suggestions and combine where possible. Also, these suggestions aren't made for trivial query plans. So due to all of these limitations, missing index suggestions are best treated as one of several of information that we have when performing index analysis. When we are tuning non-clustered indexes with missing index suggestions, we should review the table structure. In other words, before creating non-clustered indexes on a table based on index suggestion, we should review the table clustered index. Missing index may offer similar variation of non-clustered indexes on the same table, and columns across queries missing indexes may also be similar to existing indexes on a table. For optimal performance, it is best to examine missing indexes and existing ones to overlap and avoid creating duplicate indexes. There are also a few useful links that can help developers a lot. One of these is AKMS BC Performance, and another one is also Performance Developer tool that they can help a lot. And since we still have a lot of on-prem environments, on-prem projects going on, maybe I also put the last link about how to set up optimally SQL Server from on-prem, which is also helpful a lot. Yeah, I think I finished a little bit earlier. So if you have any questions, yeah, please ask me.
Hi, are there any advantages to splitting very wide tables into two or more tables? So let's say very wide transactional tables.
Okay.
Are there any advantages to splitting them into two or more less wide tables?
Sorry, I didn't hear you well, maybe.
Are there any advantages to splitting very wide table, large number of columns into two or more tables?
I think, okay, thanks. I think not, because then when we want to insert or modify or do some operations that we will need to do double on 2 times. When we want to insert some record, then if you want to have 2 tables for just one basic table, you need to keep them, how to say, one-to-one, meaning when you inserting something in one table, you should insert also to another one. Yeah.
I want to know, should we replace SIFT index with included columns, or should we continue to use SIFT index better?
I'd say that in most of the cases, we should maybe replace, if there is possibility, to include the columns, because then when we will have write operations or modify operations, it would take less time to modify or insert record on included fields than on the SIFT key. And read operations, it shouldn't be that different. Okay. Should for you.
In the future, will we have the possibility to rebuild indexes and recreate statistics out of BC code?
Okay, that's maybe a question from Microsoft. I don't know if they will. If they will.
Microphone. question was about index maintenance and statistics maintenance in SAS. And we are actually, we have planned work to do that in SAS automatically for you. So you don't have to. We have a service from a sister service where we will do it for you.
Okay. Am I give you a shirt or? I don't have any more shirts. Maybe since we have some time, I think this non-cluster column store indexes should be a really great feature. But I saw yesterday on the Voldo session, and I also tested a little bit. I cannot get really great read fast. For example, when I'm doing summing with SIFT would be fast, but with non-cluster it won't work. Even if I have 5 or 10 million cells. If it's I don't know, are there any secret that we maybe should add any other fields, or I don't know, because I see that we should add some integer fields or date fields, or but yeah, it still won't work as specified. So do you maybe have some info?
So the discussion is about non-clustered column stores and SIFTs. I think there's something important going on right now about performance discussions, that it's not necessarily only retrieval performance that you need to consider, but also insert and update and delete performance. So with SIFTs, and especially multiple SIFTs, you will get a lot of maintenance for these like non-select operations. And it might be that that is simply too expensive to have all of these SIFT indexes for faster reads, because you are now getting locking and deadlocks when you do a lot of writes. And I think that's something that might be not obvious in the performance sessions we see. People only demo the read performance and never demo the write performance. So Milan here showed the first example I have seen where someone is showing what is the penalty of having SIFTs on insert? And he said it's a 10x for one. I'm sure you have more than one SIFT index. So try to take GL, not in production, but try to take GL entry and remove all SIFT indexes and add an unclustered column store and add 500 million rows, and then start to see if your posting is smaller, like faster or slower, and maybe at that scale, this is where NCCIs really shine. And maybe we haven't seen that yet because these technologies are new to the NAV and BC community for big, large tables.
Yeah, and it's interesting that no one still, actually tried to use it. And I also look in the base table. I didn't see any usage of NCCI. Are we planning to do it?
Well, there was a question for me actually. Yes, we are planning to replace some of the SIFT indexes with BCCI or NCCIs. There is also a small caveat. If you're running on Azure SQL on a small database without much capacity, I can't remember if it's 2 cores or how the actual is, then the non-clustered column store index is automatically disabled. So you get absolutely nothing. It's just a small, if you're trying this out on a small Azure SQL database, it'll have no effect because it automatically turns off because it's a memory-intensive operation. I think the overall guidance is you should use NCCIs for tables where insert, modify, etc. That speed is important. For read, you cannot beat the indexed view because we've stored the calculation already.
Yeah, exactly. Because I use the NCCI and I use segment elimination, and I mean I have 10 segments or so, and I only read 1 or 2 segments, and still I'm slow. So yeah, I think that we will never get the same effect as a SIFT, but as you said, index and insert and modifies are much faster. That's it, I guess.